Students, this is Dr.K.Shirish Kumar, Associate Professor of Chemistry, Vignana Bharati Institute of Technology, Hyderabad. So I'm going to discuss about the molecular orbital theory of 1,3-butadiene. The reason is not far-fetched because this particular molecular orbital theory of 1,3-butadiene is very typical to understand, very typical to visualize. So this prompted me to do the video on molecular orbital theory of 1,3-butadiene. So first, let us discuss why molecular orbital theory for this 1,3-butadiene. So 1,3-butadiene is the conjugated molecule, as already we know that. So let us try to sort out what is the conjugated structure of this particular 1,3-butadiene. So this is the organic molecule, and while writing the structure of any of the organic molecule, keep in the mind that according to the name you have to draw its structure, but we need not to buttify the structure of it. Don't buttify the structure of it. Right? But means, but stands for 4 carbons, 1, 2, 3, 4. Now label the carbons next, 1, 2, 3, 4. And ene means alkene. Alkene, it is the alkene. Ene means single double bond, and as it is a diene, it is made up of 2 double bonds. It comprises the 2 double bonds. Out of the 2 double bonds, one double bond will be after the first, at the first position, and another one will be at the third position. Right. Now, this is the basic skeleton for 1,3-butadiene structure. Now, the structure of 1,3-butadiene has not been formed. This is not the actual structure of 1,3-butadiene. This is the basic skeleton for the structure of 1,3-butadiene. Now, in order to convert the basic skeleton of 1,3-butadiene into actual structure of 1,3-butadiene, what we need to do, we have to satisfy the valency of each and every carbon atom present in it. So, while satisfying the valency of each and every carbon atom, we have to know what is the valency of the carbon atom. What is the valency of the carbon atom? The valency of the carbon atom is 4. Since the valency of the carbon atom is 4, we have to make sure that around each and every carbon atom there are 4 bonds. If it is lacking any bonds, then we need to place the hydrogens over there. Now, let us apply that rule here. So this is the first carbon. Around this first carbon, 1, 2 bonds are there. It is lacking the 2 bonds for its satisfying the valency. So we need to place the 2 hydrogens. Around the second carbon, 1, 2, 3. So it is lacking 1 bond. So we have to place 1 hydrogen over here. And around this carbon, 1, 2, 3, it is lacking 1 bond to satisfy the valency of this particular third carbon. So we need to place the hydrogen over here, and around this 4th carbon there are 2 bonds, and we need to place the 2 hydrogens in order to satisfy the valency of this 4th carbon. So this is how we have to construct the structure of organic molecule. There is no need to become panic about the structure of the organic molecule. It is very simple. It is very simple to construct the organic molecule. What you need to do is, based upon the name of the molecule itself, we have to draw the number of carbon atoms, followed by we have to label the number of carbon atoms. Then if it is ene, then we have to place the double bond, and as it is diene, we need to place the 2 double bonds at first and third position. Now here, this particular 1,3-butadiene molecule is the conjugated molecule. What do you mean by conjugation? What do you mean by conjugated molecule? Conjugated molecule means if the molecule contains the alternate double bonds, or if the 2 double bonds are separated by the single bond, then it is nothing but the conjugated double bond. And the conjugated double bond containing molecules are considered as conjugated molecules. Now here, in the case of 1,3-butadiene, 2 double bonds are separated by the single bond. It is the conjugated molecule. Now why I'm emphasizing on this conjugation is, What for molecular orbital theory is designed for 1,3-butadiene? Molecular orbital theory comes into picture in the case of 1,3-butadiene in order to visualize the conjugation present in it, in order to explain or predict the stability of this particular 1,3-butadiene. So for these two reasons, the molecular orbital theory comes into picture for 1,3-butadiene. The one reason is in order to visualize the conjugation present in it, and the second reason is to predict the stability of this particular molecule. Now, if you see this molecule, let us divide this molecule into two halves. If we divide these two molecules into two halves, then it is looking like the combination of two ethylene molecules. There is a combination of two ethylene molecules. What is ethylene molecule? CH2 double bond CH2, right? If one of the hydrogen of this carbon is replaced by CH double bond CH2, then it becomes this particular 1,3-butadiene. So we can say that this particular 1,3-butadiene structure is the combination of two ethylene molecules.